look at MT4, which was our statistics and probability unit. And I'm going to go through one of each of the 2.0 level learning targets in order, starting with 4.2.1. I'm going to do one of them, and then I will leave one for you to try on your own, and then you can check the answer key. So for the first learning target, we are finding a missing value when given the mean or some other characteristic. So it says find the value of x. Well, I want to simplify my numerator by combining all of those like terms. So I'm going to add those numbers together. So I added all of those and I got 122. I'm still adding x onto that, and then it's all being divided by 7. Now, x might not always be at the end. It might be somewhere in the middle, but with addition, it is commutative, so we can rearrange things. So looking ahead at the second example, even with x in the middle, I still can add that 2.1 to my other numbers. So here, if I want to get rid of 7, I want to multiply both sides by 7 to get it out of my denominator. So 25 times 7 is 175. So I'm left with just my numerator is equal to 175. And then to get x by itself, I'm going to subtract this 122 from both sides, and we get x is 53. And then we'll save the one on the right for you. Our second learning target, we're looking at word problems involving percentages, decimals, fractions, and we have this formula that we're going to use. I'm going to do the top row this time. So it says find 41% of 78. Whenever it says of something, that's my clue that the number that follows the word of is considered like my whole number. And so that would go in the denominator of my fraction. So 41% is my percentage. However, I always have to convert my percentages into decimals. So I would divide 41 by 100, or I can move the decimal 2 places back to the left. So it's right here, 1, 2. It would be 0.41. So that is equal to something out of a whole of 78. So here I am going to just multiply by my denominator to cancel those out on the right hand side. 78 times 0.41, I get 31.98 is the value of x. This one says what percent of 33.5 is 21. Of this means that my 33.5 will be in my denominator, and my 21 is the part that goes in my numerator, and I don't know what the percentage, so I'm going to put in a variable. So I'm just going to divide those numbers out, and it gives me a decimal. I get 0.62, like 68. It's pretty long. But since I want to convert it into a percentage, I multiply by 100, or I move my decimal 2 places to the right. So it'll be about 62.7%. The next 3 learning targets have multiple parts to them, so I just have one problem that I'm going to demonstrate to you. So 4.2.3, we're looking at a scatter plot and a line of best fit, and we're answering questions. It could be anything relating to that graph, so they might be a little different on a test or on the final exam. So here it says, given that the line of best fit is y equals x plus 2, identify the meaning of both the slope and the y-intercept. So I do know my slope and my y-intercept values from my equation. So my slope, when this is in slope-intercept form, I have y equals mx plus b, where m is my slope. So my slope is 1, because that's the invisible number in front of x, so I don't need to calculate it from the graph. But I do want to interpret what that means when I'm talking about rainfall over time. So if my slope is 1, that means it's technically like 1 over 1. My numerator is talking about the amount of rainfall, because that's my rise. And then my run is my number of hours, my time. So I can say, for the meaning of the slope, there is 1 milliliter of rainfall each hour, or for every 1 hour. I want to make sure that I'm talking about both units, the units for the y-axis and the units for the x-axis. For my y-intercept, I'm looking at where my graph begins. So my y-intercept in the equation is 2, and if we look here, it's also at 2. That means there's 2 milliliters of rainfall at 0 hours, which could just be at the beginning of whenever they started the timing. So we're going to say there was 2 milliliters of rainfall. And I'm going to say at the beginning, because I don't know if it's like the beginning of the day, because it just says hours, or if starting at this time, how many hours after then. So we're just going to say at the beginning. Part B says estimate the correlation coefficient and describe the relationship. So the correlation coefficient is how strong or how weak my line of best fit is with my scatter plot. So my scatter plot is showing a positive relationship. My dots are going up. So my line is going up, and they're close to the line. There is very much a trend there, but they're not perfect and all exactly on the line. A perfect one would be a positive 1 because it's a positive slope. If my slope was negative, I would have a negative correlation coefficient. And then the closer I get to 0, the weaker my relationship is. So for this one, I would say they're pretty close to that line. So maybe somewhere around a positive 0.7, maybe a positive 0.8. And it's positive because it's a positive relationship. So I'm going to say we have a strong positive relationship. What would you estimate the time to be if the rainfall is at 10 milliliters? So 10 milliliters, I'm going to go over. That corresponds to 8 hours. And then how many hours have likely passed if there is 16 milliliters? So 16 milliliters, I go over, and my graph doesn't touch there. So I'm going to have to extend this, kind of estimate where it would end up. So maybe like here. So I'm going to extend this down. If this is 10, this would be 12. Maybe it's around 13. Maybe it's a little bit more than 13. So I'm going to say approximately like 13 or like 13 and a half hours, because I think my line went a little crooked there. We have 2 more learning targets on the back. So looking at 4.2.4, we're just determining if the scenario is independent or dependent. Independent would mean that they do not affect each other. So if something happens the first time, does not have any influence on the second time or the second drawing. Dependent means the first one will affect the second. So I'll make a little note here. Usually dependent scenarios occur if we're drawing something and we keep it out of the bag, which means there are less options for other people or less options for the next drawing. But if something is replaced, it's usually independent. So we're going to look at like the top 3, and then I'll let you do the bottom 3. So you have 10 shirts in your closet. You take one out, pack it, and then pick another. So if we're packing it in a suitcase, that means we're like removing it from our closet. So we no longer have 10 shirts to choose from. We have 9, which then affects our next probability. So this would be dependent. A spinner has 12 sections and you spin it twice. When we spin a spinner, it's not like if I land on something, I remove it, and it can't land on it again. I could spin it twice. I maybe spin different things. So this would be independent. Those 2 events do not affect each other. And the last one that we're going to go through, you have 9 pieces of fruit in a bag. You pick one out. You don't like it, so you put it back and then pick another. Since we put it back, we do have 9 pieces of fruit still to choose from, so we have the possibility of picking that same fruit out. So since we put it back, those would be independent. If we took a piece of fruit and we kept it, then there would only be 8 pieces to choose from instead of 9. That would be dependent if we kept it. But since we put it back, that's our clue that it's independent. And I'll let you do the last ones. All right, for our last 2.0 learning target, when I printed this, the table was very faint. So I have a very official handwritten table that we're going to look at. So we're looking at some gaming consoles that came in 2 different shipment boxes, and they were either deemed defective, partially defective, or acceptable. So I'm going to look at A and B, and then I'll let you do C and D. Excuse me. So A says, what is the probability that a randomly selected console is from box 2 and acceptable? So I want to figure out the number of consoles that are box 2 and acceptable. So looking up here, box 2 and acceptable are 40. So I'm going to have 40 out of, and I'm just selecting a console, so it doesn't matter what box it came from. So I'm going to do it out of the total of all of the consoles. So I have to add up everything. So I'm actually going to add up each row. So here in this row would be 15, 25, and 65. And then if I add those up, what is that, 100 and 105? So I know that my total altogether is 105. So that means I'm going to have 40 out of 105. And then when I do that in my calculator, let's just double check here. I have about 38, like 0.1% if I round that up. For part B, it says determine the probability that a console is partially defective given that it was selected from box 1. So whenever it says given that blah, 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 that's going to be our total. So the denominator of our fraction. So given that it was selected from box 1, I'm going to look at all of the box 1 consoles, so 12 plus 3 plus 25, and add those together. So when I do that, I end up with 40. So my total this time is 40 because I'm only looking at box 1. I'm not looking at everything. And then I'm looking at partially defective. So just the partially defective in box 1 is 3. So 3 out of 40. I'm going to divide those out to get my percentage, and that is 7.5%. I will leave the other 2 for you to try, and then you can check the answer key to see how you did.